The observable universe, with an estimated diameter of about 90 billion light-years, represents an expanse that challenges the human ability to conceive such immense dimensions. Yet, scientists agree that this incredible vastness is nothing more than a small portion of the entire cosmic reality. Beyond the boundaries of what we can observe lies an unobservable region that could be immensely larger, perhaps even infinite. This concept, as fascinating as it is, highlights how challenging it is for the human mind to grasp the immensity of the cosmos with current knowledge. Some theories, however, propose counterintuitive ideas. What if the universe were much smaller than we imagine? Studies on cosmic background radiation, the residual echo of the Big Bang discovered in 1964 by Arno Penzias and Robert Wilson, along with analyses of the distribution of dark matter, have led scientists to estimate that the inaccessible universe could extend up to 20 trillion light-years in diameter. This value, significantly greater than earlier estimates, suggests a cosmic landscape characterized by vast empty regions, interrupted by islands of matter organized into galaxies, clusters, and superclusters. Observing the deep sky, astronomers have identified enormous cosmic voids, regions almost devoid of visible matter that appear as vast deserts in space. These voids raise fundamental questions about the nature of the universe and the distribution of matter. But what if our universe, with all its vastness, were actually contained within something infinitely small, like a single atom? Although this hypothesis might seem more like science fiction than science, some surprising analogies invite us not to dismiss it entirely. Atoms, the fundamental building blocks of matter, are incredibly small compared to human scales, yet their internal structure is extraordinarily complex. Within them are subatomic particles such as protons, neutrons, electrons, and quarks, each of which follows counterintuitive quantum rules. This complexity suggests that, at certain scales, parallel universes or realities entirely similar to our own could exist. Ernest Rutherford's atomic model, proposed in 1911, described electrons as orbiting a central nucleus, an image that strikingly resembles the structure of the solar system. Although quantum mechanics today provides a more accurate description of electron behavior, these similarities raise a fascinating question. Do the laws of physics perhaps repeat on different scales, manifesting in analogous ways from the infinitely small to the infinitely large? One of the most provocative theories in this context is that of the one-electron universe, advanced by physicist Richard Feynman. This hypothesis posits that there is a single electron moving through space-time so rapidly that it appears everywhere simultaneously, creating the illusion of a multitude of electrons. Although not widely accepted, this idea challenges our fundamental intuitions about multiplicity and the nature of subatomic particles. If this hypothesis were true, it would lead to an extraordinary conclusion. Everything we observe could be the product of the interactions of a single particle. An idea that revolutionizes notions of individuality and plurality, leading us to consider a radically unified vision of reality. The perception of dimensions, on the other hand, is highly relative. What appears enormous to an ant is microscopic to a human, and the same might apply to us in relation to larger cosmic entities. Similarly, our universe might be just a tiny part of an immensely vaster reality. It is possible, for instance, that the atoms in our bodies contain entire universes within them, replicating the complexity we observe on macroscopic scales. The idea of an infinite scale of realities, extending both to the infinitely large and the infinitely small, represents a challenge to our imagination. This perspective pushes the limits of human knowledge, confronting us with questions that transcend our current understanding. The search for a theory of everything, capable of unifying quantum mechanics with general relativity, is one of the greatest challenges of modern physics. The Big Bang model, which posits that the universe originated from an infinitely small and dense singularity, provides a fascinating but incomplete explanation of our origins. Theories such as string theory suggest that elementary particles are actually tiny vibrating strings and that the universe itself could be an expanding bubble within a multidimensional reality. These ideas open the door to an even broader concept. Our universe could be just one among infinite parallel universes, part of a multiverse that defies our current observational and cognitive capabilities. We are fragments of a greater reality, immersed in a cosmos that continues to astonish and inspire us. Every new scientific discovery reminds us that the universe is not just a collection of physical phenomena to analyze but also an inexhaustible source of wonder, humility, and inspiration. The vastness of the cosmos and the complexity of its laws continue to push us beyond the boundaries of the known, bringing us step by step closer to understanding the mystery of our existence. Thank you for watching. Leave a like, subscribe to the channel, and activate the notification bell so you don't miss upcoming videos.